For our second example of cofunction and even odd simplification, we have simplify, and again, simplify means we're going to take this complicated expression and try to make it shorter or simpler. On the top we have sine of negative x. Now, a lot of students always ask me, how do I know when I use this? How do I know when I use that? Well, if you look back at the even odd identities, you can easily see, wrong page, you can easily see that sine of negative theta is equal to negative sine of theta. Well, if you see sine of negative x, that's the same thing, right? So anytime you see a negative inside of a parentheses and it's a trig function, you're probably talking about even and odd identities. These you need to know and you need to memorize, and that's why I showed you a video on why they're true, because that will help you memorize that as well. So we will basically use the even odd identity up here. Namely, sine is odd, right? Remember, sine, everything's odd except for cosine and secant. On the bottom, we have 1 minus cosine squared of 90 degrees minus x. Now, again, if you hone in on what's inside of here, you'll quickly see that's a cofunction identity, because 90 minus x just means the other angle in the triangle, right? And that's a cofunction identity. Remember, cofunction means pairs, and don't forget that cosine pairs with sine. One last identity you will notice nested within this, and I'll do this in purple, is you have a Pythagorean identity. Because you have a 1 and you have a trig function being squared. So we have, let's write this up here. We have cofunction identity, I like to call it cofun. We have an odd identity, and we have a Pythagorean identity. This is why the order matters. Remember, you want to do the cofunction and even odd identities first, and then take care of your Pythagorean identities. So the first step then will be to change this sine of negative x to negative sine of x. So basically what you're doing is you're taking the negative and just pulling it out. That's another way of explaining odd functions. It's just taking the negative that you input and putting it on the outside. And I will draw an arrow to indicate that. So this negative is being moved to the outside because sine is an odd function. So that's what we're going to do for the first step. Here's the negative we just moved outside. We're going to simplify using the cofunction / even and odd identities. Notice on the bottom as well, cosine of 90 minus x is equal to sine. And 90 minus theta is the same thing, right? 90 minus x. So cosine of 90 minus x is sine of x. And so we can do that in the same step. So this is just going to become sine squared of x. Remember, the exponent doesn't matter because you're just multiplying it by itself. If you were to split this apart, it would be cosine of 90 minus x times cosine of 90 minus x, which equals sine times sine, which equals sine squared. So we get sine squared for the bottom and sine of x, negative sine of x on top by moving it out. So again, we used odd on top and we used cofunction on the bottom. Nothing happened to the 1 minus yet. That will come into play for the second step when we use Pythagorean identities. That leads us to step 2. We want to use Pythagorean identities / quotient to solve the next one, to simplify it even more. Now, if you take the first Pythagorean identity, which is sine squared plus cosine squared equals 1, you can easily see by rearranging that this is going to be equal to cosine squared. And that's what I've shown here with this math right here, rearranging. So the bottom of what we have is going to become just cosine squared. And now we have negative sine on top and cosine squared on the bottom. And good thing I wrote that, because now we can use quotient identities to simplify this even more. Since we have a sine on top and a cosine at bottom, eventually that can become a tangent. So I'm going to break the bottom part into cosine times cosine. That will help me rewrite this then as negative sine over cosine times 1 over cosine, and see that this will indeed just sine over cosine just becomes tangent of x, and 1 over cosine becomes secant. Now notice, again, I like to talk about powers. The power of this function is 1, the power of this is 1, total of 2. Had my final answer been sine over cosine squared, the total powers would equal 3, 1 and a 2, and I'd have a fraction left. So this final answer is much simpler, And I've just proven that sine of negative x over 1 minus cosine squared of 90 minus x, as complicated as that looks, is equal to something as simple as negative tangent of x secant of x, simply by I used three identities. I used the odd identity by pulling the negative out for sine. I used the cofunction identity for cosine, namely it is equal to cosine of 90 minus x is equal to sine, and then I used the Pythagorean. I used 4, and after that we used the quotient identity to simplify to negative tangent of x secant of x. Remember, do the Pythagorean identity first before you resort to quotient identities. That's it for this example. Very simple. If you have any other questions about this, let me know.